Okay, so I guess we're on. And if you run this, so I've made, let's go over it slowly. So apparently this was in the original code, and I thought I had fixed it, but you see, X is, okay, when you pass X, when it's in the code, it should override the global, right? Or you only go all the way down.
You go down to the
Okay,
XA function.
XA function. So, by the way, okay. So, let me show you where we are.
See, there it passes XSA, but
No, I saw the problem where you are. Okay, so let's go over it. So a mistake was found where the start X value that you're passing needs to be used locally, right? And that I did find as a mistake, and I fixed it, and then my code worked even better. So let me show you that before we try to address the other problem that you mentioned, okay? Which, by the way, might not be a problem. So I fixed this, and this is in the Dropbox. So obviously this was a leftover from the original code, and basically, you see the start X. Oh, why is it not? Oh, it hasn't updated yet. Okay, so the start X. This is a side effect that was never intended. Needs to be copied here. Okay, so if I run source right now, let me show you. Okay. All right, so this is the problem that we know, right? If we grab it this way and we run, right? It converges. This is the one that I've been using, and basically after 10 iterations, it's kind of cool. Actually, stops are two. Okay. Oh, I guess it stops right at. Okay. Now it stops right at 10. I'm wondering if it's running the wrong code or the new code because I uploaded it in there. So if you change this to, I'm going nuts here. Is it a Dropbox problem or what? Can I save it? Save it. All right. So if I use the start X, which I was supposed to do, where your UX uses the start X that you pass, then it behaves like I just showed actually, where it's converting faster, quote unquote. Hit source, and you'll find that it works fine. Somehow I have to run it twice, I don't understand, and it's done. It's fine.
yeah, but if you scroll down to, I think it's like line 180 or something like that.
Okay, let's go to line 180. If you scroll down to line 180.
Oh no, it's a little bit further down. When you compute the energy.
Yeah, but you're passing it.
But you're passing X into that, where you need to pass start X into that.
Oh, okay. Hold on. No, you don't have to pass start X. You need to pass new X. Hold on. It is. Okay. So this is supposed, hold on just a second.
Is X visible?
Yeah, it uses the global. It goes up in the stack to the other X.
No, this is supposed to be new X.
Yeah, so that's supposed to be new X.
No, sure. I hope nothing goes to hell now.
It does, actually. That was my problem. It stops working.
So you did those two changes?
And it just stopped working.
This will be bad.
See, that's exactly what I got.
Okay. So, what are those two? Oh, this is with and without? Okay. Let's increase the number of iterations.
I get a lot of zigzag patterns too. I noticed.
Increase the number of iterations. It's obviously a mistake that they had, and I did not fix. Obviously, that's what happened here. Original. What do you mean by Okay, never mind. So iterations goes to 10. Let's try to change it so that we can modify the iterations here. Actually, I don't care about this one. This one, right? It's amazing. It's amazing. Well, I guess that's why this is the first time I really assigned the code, actually. So let's change this to 100, okay? Okay, let's run it. Is this gonna work? Run. Yeah. I have. Okay. I think it's gonna look. Now it's working. Oh wow! With optimization is worse. You know what? I have a feeling it's the wrong plot. I really think it's the wrong plot. But it okay. With opt font. Or maybe I'm wrong. Maybe it is. Maybe that gives you minimum energy. I have no idea. Let's see. Image best X of similar annealing with opt. Well,
That's a good question.
tell me.
Is there a guarantee that the ground truth gives minimal energy?
Is there a guarantee that the ground truth gives you minimum energy? If you constructed it, we did not construct it that way. No, there isn't. You mean in theory? No. Because the simulation, let me run both of them at 100, just out of curiosity. There's no guarantee because they are not drawn from the Gibbs distribution. The way you created no, there isn't. Oops, it went to 0. No? I love it.
It's still better.
Well, now it's better, but before it was. I just have a feeling that. All right, let's do 1,000.
So when I played with it back in the old days, the number of iterations didn't change much.
Yeah,
in
but
the
that was
results.
right. Let me ask you a
It
question.
depends on how you choose your seed.
By the way, the other thing that I need to understand, yeah, that might be the issue too. The other thing that I need to see here is, and I really hate working with this interface, is let's go over the code. I obviously need to test it much more carefully. What is the SA? No, that's the global code. Oh. Okay.
I think if you page down, it's more. It's easier to follow.
It's around 175.
Okay, thanks for reminding me. That saves me a lot of trouble here. Okay, so I mean, we already know there is a lot of problems with this code. Maybe I should start fixing it and see if we can get it back to work. So it starts with start x. That's the right way. The energy function passes the new x. That's the right way. This is already wrong. We know that. So this one is supposed to look at, so you have EK. All right, let's work on this one here. Just a sec.
What is that?
You have two. I just want to see a couple of things here. You're modifying new x, and it brings back new x. You see, there's something. Oh, okay. So if your thought was running on x, it does return new x, and new x was x. So I guess the problem was. Hold on just a sec. Well, x wasn't changing here. So, okay. You have the delta A between 2 and 1, and the question is which one are you on and which one are you randomly accept or reject. The probability is estimate the probability delta A. Okay. You should know where you're going. We recommended that you tested this, right? So what we said is that if we are at a pixel row column, if okay, so you are when is this code correct? If you're trying to go to 2 from 1, right? So if you are new x, and now you're going to see how embarrassingly little I know of row call. Am I supposed to do double equals or single equals?
Double equals.
Equals what? When is it correct? 1 or 2 here?
1.
If it's 1, you're trying to go to 2. That's right. Now, do I need a then or can I open a parenthesis? Yeah, I can see the example there. I needed that one, right? And then I need an else. Actually, I have a nice example over there. Else, this is the correction that I asked you to do, right? Okay, so now what you need, in this case, let's make it easier and let's call it the new val is what? 2, right? And in this case, we have that the delta x is this. This is one of the things that I asked you to do, and I guess I'm storing it. 2 minus 1. Okay, so I'm right here, right? You guys implemented this? Correction? Otherwise, the new val is supposed to be 1, and your delta E gets the difference between E1 minus E2, right? And probability is still the same, but now,
So delta E is wrong. The variable name.
well, delta is right.
Without underline.
Oh,
Should be without underline.
that's right. So now it should be this way. Now, you take the probability, of course it would be about 1, or actually let's do that minimum. Minimum, can I do it? between 1 and this one, right? Can never exceed 1, right? And you run the probability, and in the original code, okay, let's also track the energy, right? The new energy is, you're switching to E2, right? So this should be E2 from E1. And in here, the new energy is, by the way, if this doesn't work, I guess I'm going to try, but I have to obviously do it by myself and give you an update on Monday. Excuse me, so hopefully by Thursday. So this should be E1, right? Because you're moving to E1. And in this case, you need to switch to the new energy.
So that would stay.
No, it's not 1, it's wrong. It should be new val, right?
No, if R is less than probability, you don't go to the new value, stay with your current value.
Okay. Okay. And the total energy is the current energy.
Could do E of current value.
Yeah. Okay. Now I'm gonna have to go offline and debug this. Okay. Otherwise, you switch to the new val. It's amazing. I thought I cleaned up his code, but I was wrong, right? And then you get the new energy. It's amazing. It's one of those first times that I did not use my own code. Well, I guess it was my own code, but I thought I fixed him, but I was wrong. Never mind. All right. This actually brings me to the point where I am going to have serious doubts about the whole business, right? Okay. Did it run or not?
No, I think you have to source it again.
Yeah, I just did.
No, you click run, not source. I think you need to do source to update the function.
Yeah, you have to use source to do the whole thing.
This, right? I hope the code is not wrong, but if it doesn't work, if it's not obvious, then I'm gonna have to try. Try kind of like on my own time because I didn't expect this problem. Well, I mean, I knew there were issues with the code, but I guess there are more than I thought. This is something I pointed out, but I thought I fixed and I lied. I hadn't fixed it, right? So if you download his original MATLAB code, it's oh well. I may have to spend some real time on it. If it doesn't work right now, I'm gonna have to spend some real time on it. How confident are you that that code works? The one that I just did, is that the right one?
That's pretty much what I'm doing. It doesn't work for me at all.
Oh, okay. So most likely we're gonna have the same issues you had.
Yeah, I get a lot of because the neighbors only look up, down, left, right. I get a lot of zigzagging pixels
Okay.
or stuff like that.
That one went to 0.
But I'm not running for 1,000. I'm only doing 10 iterations.
Well, it's a very nasty. I mean, the theory is for infinite.
Yeah.
So there's also the temperature. If it drops off too fast, then it doesn't matter if you set your
That's right.
number of
So we need to play with.
iterations to a
So
minimum.
maybe we'll play with the C a little bit, and before we give up officially, when I go away and try to get it to work again. Okay. So I passed the C, right? Okay, you already told us that. Oh, nice connected. That's great. It's over there in the other room. Wow, it's so slow.
So are you computing, like, I mean, why is it slower now?
I'm not going to give up totally. It does look better than the ICM. It does look better than the ICM. Okay, it might work. No, it does. Look at it, right? It does look better than the other one, the optimization. So, I mean, you're really taking me back 20 years. I mean, let me think. what is it, 2013? Minus 13, minus 7, 1993. Yeah. You're really taking me back 20 years with this question. When we looked at this, when I looked at this the first time, and I was like, I mean, let me give you a little perspective here. I could have run 256 by 256 in MATLAB in 93. Because I had to make a choice. I was looking at all these Markov random. I think the answer is more iterations, by the way. It looks like, okay, maybe this and the C. Those are the two lessons that I learned. I'm not going to rerun. Obviously, if you give this answer, I will be okay. Because it's honest. I want it to be honest. I didn't mean to lie. In fact, I said it like 1,000 times that he was cheating. I put it in the comments that he was cheating. And then I found out that some of the cheating code still survived in my version. And by the way, you're talking about, I think there is a lesson to be learned. You talk about an IEEE fellow. This was a tutorial in the image processing. He's considered to be like one of the fathers of these areas, and the code is cheating. And I think the lesson that I learned, and I will go back to my teenage years, is that electrical engineers, I'm sorry, but we're not careful with code. This is the nicest way I'm going to put it. And we don't teach code. Professors don't touch code. Some of my advisor used to say, "Oh, I'll never touch code again." And the problem is that that's all you get. And the students are doing is write code day and night. And if you cheat, and then they cheat, I mean, if they don't respect that final, like you brought up, thank you, then how? I mean, we don't want to be cheated. So thank you for catching it. It's something that I had my guards on, but I obviously didn't catch it. My answer to this is right now I'm going to play with it a little bit more, or let you go. And if you increase the number of iterations and play with the temperature, the C, because like Roger said, the more iterations you do, the C needs to go down, right? If you increase it, it's going to converge, right? Because it appears in the denominator. So if you make it very large, then there is no reason to run many iterations. So that's the two things I want you to play with. And if you cannot get this done, let me know immediately. Okay? And I think that's the fairest thing to do. In his results, he was obviously in the tutorial paper. You can tell that he was not using the real X because he converged pretty fast, right? His results agreed more with mine. So obviously it doesn't make sense to do what he was doing. And in fact, to me it's kind of interesting because I don't even want to know why it worked before. I really don't. I'm too scared. The point is that if you have access to ground truth, then just copy it and you're done and cheat completely.
That's why I was if suppose you were cheating, right? You were cheating before. You were starting from the ground truth. Why didn't the final
By the way, we can do, sorry, go ahead. We can probably do, so just a second. We can probably do re-annealing here, which is, I would be very interested where you basically, do you want me to tell you what that is? In fact, you learn more by getting things wrong than getting things right. This is what I tell everybody. Re-annealing will be, I'm going to modify it to do a double for loop. Inside the for loop, you pick, you basically, because if this thing goes badly, quote unquote, notice, so this happened at some iteration, right? Just to give you a perspective of what happened here. And it's better than letting it run for 10. This is only 10 iterations.
So that was 1,000 as well.
Oh, they were both 1,000?
Yeah.
So what happened is that this thing started converging basically to something bad. Now, the model, let me ask you a question from the theory. This happened because you were at the right answer and you screwed it up. You basically let it go. However, I think I told you guys, I had an epiphany. You know, like, what is it? Muhammad went and was hiding for a couple of years, and I think all the founders of religion, like, they were hiding for a few years. Maybe not Jesus, but even for Jesus, I'm having fun. I'm sorry I don't mean to offend. If I meant to offend, I'm trying to do it equally for all religions. So I'll make you fun. But I think all of the, basically, even for Jesus, it's like nothing happened between a part of his life from 8 to 18, right? And in Hindu religion, there was Krishna, right?
Yeah.
Who was hiding, and then he came back and had an epiphany, right? And he was all about, that's how it should be done. Thousands of years later, everybody agrees with him. Well, I had the same epiphany, and the answer was, teach them optimization. Now, instead of billions of followers, I might get 1,000, but it's okay. It's okay. I don't need to be famous. I'm having fun. So the thing here is that in optimization is everything, so we can fix the problems with optimization. So a re-annealing will be, instead of running 1,000 iterations and letting this thing go. By the way, the fact that it went to 0 at 1,000 iterations, in my opinion, probably indicates that it's moving. My C is low. It's moving too much. It's bouncing too much. We can do a re-annealing, which is introducing an external for loop. Let me give you the news on Thursday, where I basically, let me give you a perspective. Every, let's say, 100 iterations, I pick the best one and we start from there. Do you understand what I said? The good news, now, I'm going to wear my optimization hat. This is great, right? Because it answers Roger's question. In fact, an even better thing would be to write the total energy outside the loop, which is something I asked you to do, and try to see if the ground truth has lower energy than this one. I mean, this is something I forced Roger to do for his PhD, and hey, it worked, right? You managed to debug your code. The good news is that the optimization is an optimization problem, and if it's an optimization problem, I'm right at home. If it's a theoretical question, then I'm going to have to redo all the equations, and that's not easy, okay? Because I basically come as an outsider to the area. Historically speaking, when these things came out, and one of the reasons I dropped it is because everybody was saying it takes forever to converge. So I was very impressed when this thing, if you ask the people in the math department, they will tell you that anything beyond 2 or 3 dimensional probabilities, 5-dimensional PDFs are very hard to simulate. And this thing is like, I don't remember how many images, how many pixels. I mean, this is pretty large. So to get this to work, you should expect to run for a while. Okay, enough. Any other questions? So at least we're not getting garbage if you increase the number of iterations. But you're getting much worse than...
Yeah, again, I'm only running 10 iterations, so, but yeah, like I said, I get a lot of zigzags, it doesn't look like...
No, 10 is, I mean, think about it, 10 is,
Yeah,
I don't believe it.
It might, depending on your perspective, it sort of looks a little bit better than ICM.
No, this definitely looks better than I think.
But yeah, I'm not running that many iterations, so...
But the paper with Bowman says like ICM is robust and simultaneous running, but because simultaneous running has like extensive computation, ICM results
He's wrong.
Is not
He's wrong.
He's wrong.
Yes.
That is the case. If
That's
you
the
take
case, I
the
mean,
last
The simulated annealing is far better than ICM and everything. And his problem with simulated annealing shows that wrong implementation, which we already found out.
Right.
Yeah, and that's only.
He knows what he's doing. Similar annealing will beat the hell out of everything. And the best proof of the fact that similar annealing is the best is that 50 years after the paper was introduced, people still use it.
And I think it's important to emphasize that you don't take the last step.
Right. You
as
don't
your
take.
solution.
Right. This is one of his big mistakes. Is that he takes the last. He's wrong right there.
So the conclusion is we have to increase the iterations.
Well, at least I think that we need to do re-annealing. Let me tell you the story on Thursday. Let me play with it a little bit, see what happens. Do you understand the re-annealing? You do a double for loop, okay? Where it's not a re-annealing. It's a standard method. Look, you go back to instead of taking it all the way down, which is what he did. Basically, my understanding is re-annealing is that you rerun annealing. Similar. Okay, let me tell you there are many ways to do it. I'm sorry. Let me try some of them. You can have multiple starting points, which was the code that I gave you. Okay, basically you start with ICM and which is here and add some random noise to it and basically create multiple starting points. Another thing you can do is kind of stop the annealing in the middle of it and run it. By the way, I'm going to have to do some more research on re-annealing. But basically, my understanding is that you just rerun it and you go back to a better answer that you already had. And that way, if I was to run now with that one, most likely we'll get to the right. And if you think optimization, it makes sense. You're basically close to the right answer. And then you run away because that's what similar annealing does. It allows you to move around. It doesn't get stuck to local minima. But if the answer is around that local minimum, then you go back and redo your search around that. So there's a lot of things you can do here, and I love them. But the most important thing to do, if I don't get it done by Thursday, is because I'm going nuts with other deadlines, is to compare the energy functions between these three. Obviously, this beats that one, and that's great news. Otherwise, everything. See, I don't really. Let me just repeat myself 1,000 times here. I don't really care what the professors are saying about the running of the algorithm, if the fundamentals are wrong, which is the energy going lower? If the energy is going lower, then the answer would be let it run for a while, and work on. This is an optimization problem. Your algorithm, okay? And if they knew if they studied, and I spent a lot of time on the optimization, they would get everything they need. And again, those questions have been answered with bugs. I mean, this is not question. Bayesian is considered mature technology. Okay? This thing has moved on now to graphical models, as I presented to you last time. So obviously there is something fundamentally wrong with the algorithm and not the theory. Okay, I'll talk to you later about this. Okay. All right. Thank you so much, and feel free. Again, the only reason, well, you don't need the data. Okay, so I want to talk a little bit more. So I guess now that I exposed myself. I mean, how many? It's a very short list of professors who dare to write code to me. I don't blame them. And there is a lot. Actually, most of us don't write code, and some of the time I feel like writing code is wasting my time. Yet, when I get people actually go into it, I feel proud that I did it. I don't know how to describe it. Can I get rid of this?
What is this?
Bring out the ribbon. Focus used to work. Okay, so all right, so I fixed this, and I guess I'm going to look at it again. So I put that comment about StarDex. I already fixed that. So if you go back to my code, you'll find the other thing that I did is that I changed the homework, and we're going to be talking. There will be no other homework. This is it. And then, of course, from now until the end. By the way, almost how many? There are only 3 people taking for a grade here. 1, 2, 3, right? Okay. So basically, in order to make an A, we need to make sure your project is good. The other 3 are taking it, no credit, or just having fun.
I'm going to do both.
Well, just need to get the project done right.
Yeah.
Okay, and that's all I'm looking for. And if you screw the project, then you won't get the A. Sorry, I went on record. And then I actually started grading, and I'm a little horrified by some of the answers, so I'm going to have to talk about the homework solutions. But after your presentation on Thursday. So on Thursday, basically, I want to see where you are. They are not blowing it off. And, okay. Because if you are, then you're in trouble of not making the grade that you would expect, and we need to talk more. Understand?
So it'll be in class, the presentation.
Yeah, and I didn't give guidelines because I wanted to be interactive, but the guidelines are the same as the final, if you want to read. I think the PowerPoint for the final. And you can take as much time as you need, because from now on the class is about feedback. Homework, the only other presentation after today is the one on machine learning, which relates to this. I mean, this is the last homework, and the goal of this homework, which is, the reason it's due December 3rd is so that I've been extremely flexible. It's all about, you can tell me when you're done, basically, and I'll see if you have a problem. Obviously, if you didn't do a homework, that's a problem. So the big question here is, how do you fit the model? Notice that another way we are cheating here, as if we didn't have enough cheating going on, is that we know the mean and the standard deviation. So what happens when you don't know the mean and the standard deviation, and you start playing with numbers? And the only thing that might save you, and this is why I demanded that, is that if the energy functions are really bad, the energy values that you get are really bad if you plug in another model, right? But in this case, because you're talking about a distribution of 3 objects, right? You have 3 objects. Notice that you could estimate the mean and the standard deviation. If somebody gives you an examples of what you're looking for, you can estimate the mean and the standard deviation and plug that in, okay, from, let's say, real values. That's the first thing to tell you. Second thing to tell you, if you can't have that, then you can do what I'm talking about here. And I'm going to treat this as extra credit, this second problem. It's meant, if you had a problem with one of the homeworks, do it. And I will let you know next week, when I start going over each one of them. But notice that if you have what you can do, you have 3, you can look at, you have 3 probability density functions, let's say, in the basic problem, the background and the 2 objects, right? So you could just try to fit them using least squares, non-linear least squares, okay, which we covered. What happens there is that the parameters are the mean values and the standard deviations, and you plug them in, and if you plug them in, and you have to clip the histogram, right, from 0 to 255, doesn't make sense to go beyond that. And then you plug in the equations from the 3 distributions, and out comes a histogram, okay? And that histogram you compare against the histogram that you estimate, and you get an error, okay? And that's the finest error on Earth. It's a least squares problem. You actually fit it. There are special ways to fit those in MATLAB. You basically fit the whole vector of errors in MATLAB. You don't sum it up. And then it will run basically a Newton's base that will converge really fast and estimate the sigmas and the mu. So this first part is the best way I know, easiest, assuming that your objects are large enough, right? Because your objects are tiny, then those PDFs will go 0 in the histogram. You won't be able to see anything. So if the objects are large enough, the easiest thing to do is to fit the histogram. Another thing you can do, which is probably, and of course the answer might be a combination of these two, is to just do a search, or just a stupid for loops, right? Just go through those. And then for those of you who have taken optimization, you know that this is one of the first assignments. So basically, this is what is called a global method. Just for loop over a bunch of mean values, a for loop over a bunch of standard deviations. And then but for your sort, just to be able to search it right, just search, put the 3, you need a natural ordering, starting from the left distribution to the middle and right? In other words, there's a lot of symmetry in your search, and you need to, for things not to go, for you not to be searching forever, assume that one is You understand what I'm saying? One will have a stand. You can sort the mean values. One of them will have a smaller than the other, and that way your search is a little bit of constrained. So that be again. That's a way. That's one way to do it. Just search through mean values for all three, and then change the sigmas in the internal loop, and that way you have. It's a very large number of points, but that way you will have what is called a global method. Now, if you wanted to really do the problem, again, as a student of optimization, what you can do is do a random initialization on your parameters, like the global code that I passed out early on. Remember, I passed a similar annealing optimization method. You can use that, actually, to solve this problem as well. And that would be wonderful, the code that I passed out, which is, again, this is all optional, but it relates to your project. That's why I want to talk about it a lot. You do a random initialization on mean and the standard deviation values, and then let similar annealing solve the problem for you. Okay? It will try from all those random points to find, and you can increase the number of random points, and that way you can handle a very large number of parameters relatively. And not only that, you have a global method that doesn't suffer from issues. Of course, again, in terms of optimization, and that approach can handle the discreteness of your data, and you need to define neighbors and things like that. But the best approach is the first bullet. You feed it to non-linear least squares, because that's a very effective way to do it. And then, of course, you can do a hybrid where you do a bunch of random points and just run the local non-linear least squares. Again, those are the obvious ones that I see. Okay, and our notes have more. You saw them. They talk about logs and all that. But I don't know what to tell you about. I'm not up to date with what is best. I guess Hamid was supposed to talk about the latest papers. Maybe he'll give us a presentation later. Are we clear with this? Okay. Now let's have a little fun. Okay. Again, this second part is going to become optional unless you have problems with the homeworks that you skipped one. Okay. So the last piece. Is that it? Oh yeah. Let's talk about this. Remember, I'm giving you presentation examples, and that way you will. The hope is that you know what to do in December. You're not being graded for Thursday and next week when you present your stuff, but in the final presentation, make sure, or if you want guidelines for the rough presentation coming up. That's why I'm doing these 3 presentations. By the way, I have a question for you. I'm going to meet with the Science and Technology Corporation. Does anybody know who they are? STC? STC. You can write. Okay, STC is the corporation that is responsible for commercialization of UNM technology, which actually it used to be a completely useless organization, and now it's become a respectable organization that is making a lot of noise, including this morning they got $3 million pledge. You can find the Daily Lobe upper right. And I'm supposed to meet with the CEO because I put some ideas in email, and I guess they're finding them interesting. And I told them that the students might want to do it, so I need to take an informal poll here. So here's my idea: was to, instead of trying to go after the professors, which is on starting up companies, the idea is to fund the students to start up companies based on their theses and dissertations. It's not so original. It's exactly what Google and Yahoo did. Okay? It's not original at all. And the concept will be, I have one awarded patent, let's say, and I'm about to get, maybe we file another 3 or 4, and other professors have much more, like 4, 5, 6 patents. The goal will be to make all the patents available to all the students for nothing, except if they make money, they have to give back some money to pay for the patent cost. and you guys will stay in your dorm, and they will fund you to work on your PhD, develop code for your PhD or bachelor's or whatever you're working on, and keep the cost down for UNM technology. Unless you make money, you give something back. Would that be interesting? How many of you would do it? Oh my God, are you serious? I only promise them one per year. That one student per year will take it. I can get 60%. Okay. It's not it's exactly what Stanford does. Okay? How do you think all these companies, my understanding, I don't know if it's legend or just the professor, the guys at Google, they just went over, the professor taught an algorithm for finding things, right? They took it, of course they made it work in server. They did a lot more than just take the code. They took his code, and whenever they made some money, they came back to the university, they hired a bunch of students that worked, and I think the professor got some money on the patent, right? Notice how it's different than what is happening right now, which is a professor pushes it. Because come on, for me, the idea will be to teach free and open source software, work on your PhD, right? Maybe we'll have some issues, but that's what the university needs to figure out. Pass the intellectual property to the student, let them make money. If they make anything, get something back. If they don't, leave them alone. And you get to stay. Oh, there you are. Okay. So anyway, that's okay. I'm going to discuss it with our CEO. So I'm impressed by the response. Okay. So now let's go over here. This was also in London approached for starting a bunch of companies. So the British are after this because Andreas is at Imperial right now. So I want to talk a little bit about this area. We saw it before. I want to talk about what is driving the mobile healthcare and give you a perspective. So this is huge in the sense that this is how the future of medicine will look like. Okay, this was published in the IEEE Singapore magazines in November, which is this month right now, which is the top IEEE in terms of impact factor, the top electrical engineering. So this was an invited paper too. We didn't go through a review. They wanted us to write the paper. So if you go around, you will find that there is an incredible amount of research being done in many universities. For example, MIT, Georgia Tech, they spend a lot of time on body area networks. MIT has the famous ECG database, the arrhythmia database that won a lot of awards, all pre-segmented ground truth. Georgia Tech works on clothes that are full of sensors. So this is a pretty big area for many universities, okay? Why do you want to do this? First of all, everybody, you hear this all the time on TV, the new generation will live to be 100 or more. Anybody born today was likely to be more than 100 years old. Current retirement age is at 65, 67, 70. I looked it up. They probably raise it to 80. But by the time the young boys are, but no matter how you do it, there is a very obvious problem where you have chronic diseases. This is a very relevant problem in the United States. It's even worse in Europe. I don't think it's a problem in Iran because they have a young population.
Oh, it's getting older gradually.
But your average age is probably 32 or 40.
Yeah, it's not getting older because reproduction rate is much lower.
Yeah.
It's less than 2 child. So.
And China is waking up. They just approved the 2 children per. India, so they realize that unless they have the young workers, India never had a policy, right?
No.
Okay, so I would put a lot of money in Indian companies right now because even though the European company, the European Union, the United States are the 2 biggest. In terms of the elderly population, unless something happens, like we open up the floodgates of immigration in this country, that's a solution that has been proposed. It's going to be a bunch of elderly people, and because of the baby boom generation, right after World War II, there were There was a spike in births. Those people are retiring. So to cut it short, going after the elderly is a huge market. Okay? If Europe needs it, United States needs it, India maybe not. China woke up because they were sitting on a time bomb. It's a bunch of hydrogen bombs, but they woke up and they're changing their ideas. And if they continue the same way they were doing it, they will have a bigger problem than the United States. Okay, so here's what's happening. We went from 2.5G, 3G, 4G, right? So the networks are going up and they are providing more and more bandwidth. Most of the United States healthcare system, and this is prior to, I don't want to say Obamacare, but let's just say the recent change of direction in the United States healthcare. It's not just what the Obamacare, there's a change of direction if you go to NSF, NIH, on the way healthcare will be done in the United States, which will be more personalized. And I want to talk more about that. But here is how it looks like now. Most of the uninsured go through emergency healthcare, which is a disaster, right? Because this is extremely high cost. There's no prevention, right? And I mean, it's like the worst way to do it. Just put them all in the emergency, in the ER. You can imagine mixing the real emergency cases with the uninsured. Okay, it's an explosive mixture that is destroying the U.S. GDP. There is no doubt that healthcare is by far the worst technology in the U.S. I had a presentation in the department here where I started screaming about firing everybody at NIH and all the people involved with healthcare. And then I thought I lost it. But with the recent screw up with websites, I think there is a lot more voices than mine. It's true. It's a waste of time. Government, healthcare, the United States has a problem right here. Okay. At the same time, there is a large number of technologies that are coming out. Remote diagnosis, second opinion, not done in the U.S., telesurgery, triage, and medical education. So all of these things are high growth areas. Okay. Electronic health records. By the way, that alone will solve the problem of the high healthcare. There was a study, I think it was done with the VA, by just going with electronic health records, basically switching to databases like we discussed. You go from a money-losing operation hospital to a surplus. And this was proven in the United States.
I looked that up after you mentioned it, and Presbyterian is the only major hospital in at least this area that has electronic.
That's right.
They do have it, and you can get on anytime, see what you got.
And personalized.
Yes.
That's another thing that give you access to it. So anyway, so that's another dimension. All of those things are. The nice thing about the U.S. is that we seem to innovate and turn everything to an opportunity, right? But it has not happened in healthcare. This hasn't happened, and the frustration is significant. And I love the frustration. In a way, I'm happy that the website screwed up because it woke up people. Because if the website was a success, maybe now they will find all the things hiding under the rocks. You know what I'm saying, right? This is nothing compared to the bigger problems. Stupid website will probably be running somewhere middle of next year. Don't what they promised in December. I'll make you fun. I'm sorry. All right, I'm having too much fun. Then there is the smartphone and tablet revolution, right? Which a lot of doctors get those things. And then you've got things like UNM is a leader here. By the way, UNM, we have leadership in emergency care. We have the center, helicopters that fly, through like 3 states. We are very big leaders here. That makes sense because we are a nuclear state and we need to have a great disaster crisis management team right here. And we are also not from the engineering, but from the perspective of deployment in telemedicine, right? That's what employees Hammett, right? And obviously, Jadla got a job right here. because they are trying to go with electronic health records. So these are not trends that are going to go away. These things will grow. Okay. Anyway, so the big point is I want to talk about this, and the prediction is that our group invested a lot of time. We're kind of leading, as you'll see, and that this is what the future is going to be about. It's not going to be about where MIT and Georgia Tech are putting all of their energy in. I see the future is going to be about video communications. In fact, it's not even the future, it's the present. But it will eventually become the future of healthcare, which lags technology trends by anywhere from 10 to 20 years. So actually more like, feels like 30. And I'll show you the graphs. So why should we study it now? Because we have AGVC. Okay. So images, yeah, they used to transmit a picture. I mean, that's what you're really looking at with electronic health records, right? People look at images all the time. But things are going to be all about video. Okay? The prediction is. AGVC this is very big. First of all, it's a new standard, so that gives you, and we are leaders, we wrote half a dozen papers on it, including this journal that I presented a slide ago. So it makes sense to look at it, but one of the biggest reasons is because it supports high resolution, because the first thing you do in medicine is you acquire one and then you translate to something else. So just in that step, you lost. As you shall see, AGVC allows you to go to the same in-hospital resolution. That is a breakthrough, because that means that what is holding back everything, of course, it's the idea that you might get sued if you get it wrong. And if you could reproduce the video quality inside the hospital, you are able to deliver that remotely, then obviously you cannot get sued. Let me repeat that so that you understand what I just said. If you use AGVC with a very high resolution, whether it's frame rate, bit rate, or spatial resolution, and you have proven, and I'll tell you how you prove that there is no sacrifice in diagnosis, I'll show you how that is done, then that will be a turning point in using mobile video. Okay, the other thing that is happening is that with mobile communications, you can get 80 to 90%, right? Or in fact, in Africa, the mobile or the wireless revolution kind of, correct me if I'm saying this wrong, but basically they have more wireless coverage than they have wired coverage. So it's kind of like this, right? I mean, mobile phones, in fact, believe it or not, if you want to go and find incredible applications of wireless healthcare, you go to Africa and India, especially Africa. When it comes to basic text-based messaging, you'll find lots of papers about how they avoid. I had a student who wanted to do it, and I should have let him do it. I was worried that he was going to talk about the policy in his country. I don't remember which one. And I should have let him do it. Instead, I was worried about, are you going to have enough engineering in your paper and whatever. Okay. So there is a mobile revolution happening. Okay. In the case of India, they do the telemedicine revolution.
With the ISRO, they're doing a lot of satellites, and then India has like 900 telemedicine centers. Like
how many?
900.
900.
800 only in India, and then the other 100 is for the Middle East and for some of the African countries. Using ISRO satellite strong they provide this kind of telemedicine. So
that's another. So India has strong interest in doing this. Okay.
You know the thing, like they use MPEG-4 for that.
Yeah, that's fine. At least they're using something, because here, when I spoke to them, they told us that they're not interested. So, I mean, the stuff that is happening at the Center for Telehealth is nothing compared to what's happening in India. I know that for sure, right? Okay. They think what they do is they go to, and I had Peruvians, like, where are my Peruvians? They go to like a very isolated place in Peru, which is nowhere close to Lima or any other place that I've seen in Peru. Find the most isolated people that haven't seen. Most of them haven't seen computers, at least to the people that I spoke to, and they say, and then they show up, and and they scan them with an ultrasound and they say, oh, that's beneficial. They completely miss the point. Okay, it's like this is about replacing what's happening right now, not about finding people that haven't seen technology to show them. I mean, anyway, but believe it or not, that was the telemedicine published research for 10 years. Go to remote Latin America. Peru was a popular, I don't know why they targeted Peru. Because it has isolated regions, probably. Because when I visited Peru, I didn't see any of that. So, okay, so open issues. If you're doing wireless, you're dropping frames. So you need an error-resilient method. Okay, we spend a lot of time here at UNM on that. With UC1. Okay, the other thing is that every study that you find today about the available data rate, what happens is that ultrasound technology resolution goes up, and all of a sudden that bandwidth is not enough for the next generation of ultrasound. And we have found that the growth in resolution is faster than the bandwidth growth. In other words, they can't keep up. The equipment, I mean, some of the ultrasound machines can deliver hundreds of frames per second. Hundreds. I don't know any wireless system that would deliver that. Okay? Or wired in real time. So what's holding a lot of these things is the fact that everybody claims to have done it, right? You go over there, you go to the hospital here at UNM, and you'll find they're holding tablets. Okay? But the problem is there is no quality guarantee. So if they ever, let it be known that they diagnosed the patient on this versus they just looked at it quickly. In other words, instead of wasting their time looking at it, the official line is they should be looking at the patient directly, because there is no real protocol that guarantees that the clinical diagnosis done remotely is equivalent to the one you do face-to-face. So as long as, and that's exactly what the problem is for video, ultrasound video. Now, if you do it remotely in India, I have no idea what the guarantees are, or what, but probably there are none, because first of all, they're not bound by US law. The point is not about sending your images to another country so that you avoid the insurance laws of the current country. The point is, how do you make the best technology out of this? I'm sorry, I'm having too much fun. So you really need to develop clinical criteria, and this is not an easy problem. Yes?
So do you think the face-to-face communication, I mean, the quality which we see in hospital will really match in a remote location?
Yes, I think we could match it, of course. You know why? Because there is so much detail you can get. I live on Skype day and night. I mean, obviously I believe in it, but you need to create the criteria for it.
Right.
Let me repeat it. You need to have a criteria for it. And there are also three different problems there. There is the wireless, which it's very tough to guarantee anything. Almost nothing. There's almost nothing you can guarantee in wireless. The network can go to drop immediately. Second, there is the download, full video download, where you can guarantee everything you want. And third, there is the streaming, which is also hard, but it's not as bad as wireless face-to real time. The problem is the bandwidth can drop at any point. And what do you do then? How do you guarantee anything? Okay? And so the answer would be to develop clinical criteria. I mean, think about it. There are no criteria. Right now, video quality assessment is considered to be an open problem. It has not been solved. Most of the methods fail to assess video quality. Image quality is far better. There's absolutely nothing in clinical video quality assessment. Almost nothing, except, our group is doing something. If I were writing a paper, this paper, I'll show you of how to guarantee clinical video. Okay, so, and there's also the adaptation problem. So what you really need is fundamental research in clinical video quality assessment. So this is where our lab, this is what you guys are working on, half of the people here. So very quickly, we're after one of the biggest problems in the Western, whatever that means, Western. You go too far west, you go to the east, you know how it goes. Because we're on a sphere after all. Okay, so I'll have you fun. So stroke is one of the biggest killers, especially if you're going to have this elderly population. Stroke is cardiac and stroke, which is the same problem really. It's just in the cardiac problems you have plaques here inside the heart. In the problem that we're studying, it goes to the brain. It basically everybody has the problem. I mean, everybody has plaques. Everybody, if you wait long enough, if nothing else kills you, stroke will get you for sure. Okay, so what is happening is that right here in the carotid artery, the bifurcation, the recommendation has been, and this is where UNM is one of the, we have a vascular surgery, Mark Langston does that. If a plaque develops right here in the bifurcation, you see that, then they open it up and remove it. The problem is that there is a 2-3% chance that they will kill you if you do that. And there are big fights over that. In fact, the most recent fight was a couple of days ago about cholesterol lowering and what do you do. And it's all about, basically what they're talking about is how do you make sure that the plaques don't deliver. This is something that you should never do apparently for these plaques, even though I'm sure they do them all the time, which is they open it up, because it is far more dangerous than taking it out. And I think this is, at least at some studies that I have seen, this is probably more dangerous than leaving it alone. But it looks good. Would you rather see plaque or this? So, okay, so the group, collaboration with Cyprus, we don't have it here. They have developed over the years the segmentation method, okay, and that is done here. In other words, there is a new paper to come out at Tibor Transactions Ultrasonics 2014, video segmentation. Forget it, it's something we consider done. We can get it from them. The Dr. Nikolaidis will develop the guidelines for how do you treat these patients. And he's working with us, he's retired now. Gave us this idea. So the problems, you have issues where different pieces are moving at different speeds. You have dark regions that are very dangerous, especially if they're close to the top, because they represent a lipid core, and that can break and go cause a stroke. Solid echogenic are not as dangerous, and maybe if Hamed presents, maybe his work will show you that he also came up. Everything was going to hell in terms of somebody published a paper that this motion estimation is going to work. It's called what's the name of the guy? It's a German group. I don't remember him. Anyway.
Lucas Canard?
No. They published a paper about this stuff in 3D long time ago, showing that if there is motion on the surface, you could predict the stroke. But it turned out that we could not reproduce it here. And there's another group in Greece that I sent some email to some of you, and they came up with the same conclusion. You could not reproduce our findings. So in Hamed's last year paper, Nikolaidis changed the requirements, where we show that the motions along the plaque are very different. He came up with the idea of discordant motion. Instead of trying to determine the fact that they will cause them stroke, you try to see if the plaque is moving like a solid object or not. If it's a solid object, it goes up and down. If it's not solid, it moves in different pieces. And that is wonderful. First of all, it moved the area, because before that we were stuck. But the most important thing of him doing that is that it changed direction into what is called personalized medicine. Let me explain that, okay? So right now, most of medicine, this is the old way of doing medicine. And the United States current system is undergoing a huge transformation from the old way. Old way was, look, you can go smoke if you like, but I'm going to warn you that you're going to have increased risk, right? But there is no real reward system in the system where it says, okay, if you stop, you're doing 2 packets a day and you go to 2 cigarettes a day. The doctor doesn't really know I mean, they're not telling you. Oh, there's nothing that they're observing that tells them that you have improved. So basically, in the old system, we know that in the long run you're likely to live longer, but that's not the way to do medicine, okay? That's the way the system was destroyed. Everything was pushed to the ER. You have to predict long-term things. The personalized, which is where the US and British have gone that way, but of course the US will lead if they put money in it, is they, look, here's the plaque, here is how it appears today, and you change everything, you started exercising and so forth, we could see that the plaque motion is changing. We could see that the lipid cores are perhaps being reduced. We could see that it's not moving as fast, right? That's the personalized approach. You start measuring things on the patient. You move healthcare back to the patient. Instead of the doctor waiting for something disastrous to happen, right? You progressively assess improvements. That's the way it should be. Okay? And it's a general trend. They want to put you on. For example, we know that in long-term effects, you can solve most of your cardiac problems by exercising a certain amount, right? So in the old ways, we'll just go, we'll say, oh, bravo, there is no real way of assessing. In the new ways will be count how many minutes per week you exercise, right? Get the reward system up and running, where the doctor is not interested in just your cholesterol level. They actually measure all kinds of personalized things, and also you keep track of it. You get up in the morning and you look at it. Diabetic patients do it all the time. They measure their glucose. They have to monitor it on a 24/7. That's where everything is going. We want to monitor your blood pressure all the time if we could, and keep it low throughout the day. Don't expect to send the results to the doctor. Do it to yourself. That's the new trend. So the first thing we did is we came up with, so based on this idea, came up with this criteria, right? And this is the traditional criterion of measuring stenosis. But notice that we have added, based on fundamental research that we do in this area, in the latest publications, including the New England Journal of Medicine that Nicolai got in, the plaque morphology and type of plaque that is going inside is interesting from a single exam. But then, of course, the reason you need video, which is very few groups really do this, by the way, we're really looking at being ahead of what is happening in today's exams. Today's exam is mostly about stenosis, especially in the lab, and maybe blood flow. The good groups go into morphology. Almost nobody's doing motion. But it makes so much sense to do motion because there is evidence. There is mechanical evidence. I mean, how does things break? If there's no motion, nothing will ever break. So the goal is so now we have three criteria. One has to do with motion, and the other two have to do with still images. And then if you're going to do personalized medicine, this is completely new. Nobody's doing this. I mean, all of you have you ever seen them? They completely forgot what happened to you last time. Heck, if you move from one office to the next, most of them won't be able to pull up most of your records. I mean, except maybe for Presbyterian. So if you want to talk about personalized medicine, then we want to talk about increase, same, decrease, same or changed. I mean, you really need to talk about changes associated with the video. Right now, what they will do is basically remeasure it, and they probably hit a different point. And so what they end up operating most of the cases, even though according to Nicolaides that's wrong. But it's the only way to remove the plaque and not see it again, is to operate on it. But the probability of killing them because of the operation is about the same as leaving it there for most plaques. That's why he's objecting to that. Unless we give them the imaging technology to properly track the change, people will still operate. That's the message that we got. Okay? So we have a grade from 1 to 5. Again, please don't worry about the problem as much as the implications, because everything I say applies to everything in medicine. They are being transformed. All of the research groups that get awards are moving to this personalized, follow-up, continuous lookup, 24/7. You take care of yourself. We give you the information, but you figure it out. In case of Hamed, he knows more than the doctors. So okay, so in the paper we presented, we're having fun. Well, that's what the doctor said anyways, last time when you impressed him with your knowledge. So we came up with a generic system for encoding video. Okay, so here are the pieces here. Pre-processing involves medical video denosing, segmentation, and in the past, it involves spatio-temporal conversion, which, as I said, in AGVC, you don't have to do that. But if you're going over the network to send it to India, I'm sure you're converting.
Yes.
You should go back and can we find like 10 of them, not all 700 of the telemedicine centers in India, to work with?
I spoke to a doctor, one of the doctors. He's from India. I know he is one of family friend. He said yes, in his hospital they are using telemedicine center and it is accessing ISRO facility. They are using the data from them. And when I was talking to him, he said they are using only normal computer monitors, the CRT monitors, to see the video. I said, is it okay? Can you see the patient and can you see them diagnosing it? Yeah, sometimes it doesn't. We don't know what the patient is like.
Well, two things happen there. Number one, the Indian doctor is patient. So he's willing to put up with 2 minutes of garbage so he can get what he wants.
Yeah.
And second of all, as I told you earlier, from the US perspective,
Yeah.
the image left the States. I don't think he can be sued. Ask him about getting sued because I'm having fun. The point is that, look, but that's a big mistake. The fact that they think that telemedicine is done for rural regions, like where Hamed is working. And, I mean, it's really dedicated for the poor. And the answer is, that's not where my group wants to work. We don't want to develop this for the poor. We want to develop it for the best healthcare possible. You understand what's going on? I mean, their argument, this is the basic, I won't call it racist argument, but basically, the poor wouldn't get anything anyway, so whatever we throw at them through telemedicine, they should be happy. I mean, that's what I see in these arguments. That's not where we want to be. We want to change healthcare for everybody. And by doing it that way, the poor will get the technology that wasn't developed for them because they get nothing. It was developed for everybody so that they can get the greatest healthcare they can get. That's the argument, okay, that we want to push. All right, and hopefully get you jobs because ultimately that's the only thing that matters. Okay, so in the wireless transmission, we have, and I'm sorry, and I'll pick it up next time, unequal error protection. That's one thing we use. Oh, by the way, part of the group, Andreas, is we work with, we changed the networking. We actually put the terrain as well. The ambulance is moving at 60 miles per hour. This terrain, these are the wireless stations. How much bandwidth can you get? And he investigates this unequal error protection. You can do bitstream prioritization where the plug will go through a different channel. You could do even selective retransmission, even though we don't do that. What we do is we do encoding that is supposed to survive. So we have all these parameters that you'll find in our papers. Delay in the network, GDIM, packet loss rates that affect this part alone. And then there is the post-processing, you bring it back, you reconstruct the pieces that are relevant to the diagnosis. The plug is not going to be treated the same as the blood vessels, because the plug is where all the action is. So we're going to make sure we're going to protect it as much as we can. So we have objective video quality assessment based on what I told you. And in the traditional, this was a special issue in IEEE multimedia a month ago. In the traditional, you have full reference and no reference. That is, full reference when you have the original video, no reference when you try to guess without having the original. Huge frontier, no reference video quality assessment. Okay? And I'll leave it like that, and we can talk next time. But This is the presentation, I guess, of a couple of weeks ago. See, this was supposed to capture, believe it or not, our group, meaning UNM, UCY, does research on all of these boxes I use here. All of them. We can put the network. We can put the wireless, the terrain. We can put the ambulance moving. We have it. You find it. Changed to WiMAX, or now looking at 4G. We can do the segmentation and do VQA. We have worked on everything. I mean, literally everything. Okay, but the next frontier is up to JADLA, because it's all about fields too. We'll talk about it later. All right. So it looks like it's going to rerun it with higher number of iterations to play with C, and I'll play with it too and see if I can get something better to show you.
I'll mess around when I get home.
Oh, so when can I get together with you?
Tomorrow morning,
At what time?
I should be available after 8. But after 8, that doesn't mean we meet at 8. I can look at my schedule.
All right,
Just
I
give
mean,
me a sec.
11 might be a good time.
It's okay. You can do it
Okay,
late
that's
afternoon
fine.
as well. Okay, now I think I was recording, right? Oh yes, I was. Now if I can find it, I think we found out that if you
I-
quit,
well, yeah.
it